Welcome to this explainer. Let's just be completely honest for a second. There is literally almost nothing more frustrating than writing a beautiful piece of Python code, getting all hyped up to see it live, and then Streamlit and Google Colab just completely refuse to cooperate. You run the cell, and it either crashes, spins forever, or throws an error code that looks like it was written in some ancient, hostile alien language. You're just staring at the screen, your excitement totally deflated, wondering what on earth went wrong.
If that sounds familiar, I really want to validate your pain right now. You are absolutely not alone in this. In fact, so many students in the recent Penniversity AI 101 cohort have been pulling their hair out over these exact same cryptic errors when trying to combine these two tools. It really begs the question, right? Why do these two amazing platforms seem to hate each other so much? But hey, don't worry, by the end of this explainer, we're going to clear all of that up for good.
Today, we're giving you a foolproof, golden path to get your web apps running flawlessly. We're going to quickly cover the core challenge, the essential setup, how to connect the nrock tunnel, actually launching your app, fixing that dreaded disappearing files issue, and we'll wrap up with a master troubleshooting clinic for those common errors. Let's dive right in. Section 1. The Streamlit Colab Challenge. So, the main conflict we're facing here is actually fundamental to how these platforms are built. Google Colab is an incredible free environment for running Python notebooks in the cloud. It's amazing for data science. But Streamlit? Streamlit isn't a notebook, it's a web framework. It fundamentally needs a way to display its user interface to the public internet through a web port. And by default, Colab just doesn't leave web ports open for the world to see. That right there is our primary roadblock.
Section 2. Essential Environment Setup. Okay, now that we actually understand the conflict between Colab's closed-off notebooks and Streamlit's need for an open web port, let's get into the practical steps to configure our coding environment the right way.
We've broken this down into 3 super digestible, step-by-step actions just to get things rolling without the overwhelm. First, we need to actually bring Streamlit into our environment by installing it. Second, we install PyNgrok. That's the crucial Python wrapper for the networking service that's going to act as our bridge. And finally, we create the literal canvas for our app, the app.py file. Taking it step by step like this really prevents the environment from getting tangled up right out of the gate.
Now, there's a tiny detail here that will save you a massive amount of headache, and that is the -q flag. When you run your installation commands using that magic exclamation mark, like pip install Streamlit, add a -q at the very end for quiet. If you've ever run a standard pip install in Colab, you know exactly what I'm talking about. It generates this massive, messy wall of text detailing every single byte being downloaded. It's overwhelming. The quiet flag brilliantly hides all that panic-inducing output and keeps your workspace clean, tidy, and totally focused.
Section 3. Connecting the nrock tunnel. This is exactly where we bridge the gap between Colab and the outside world. For a lot of students, this is honestly the most confusing part. Think of Google Colab as an isolated, incredibly secure fortress. Your Streamlit app is running flawlessly inside that fortress, doing exactly what it's supposed to do. But you, the creator, are stuck on the outside without a key. Nobody on the outside can see it. ngrok is a service that basically digs a secure back tunnel from that isolated server straight out to the public internet. It gives your Colab environment a public URL so you can finally view and interact with your Streamlit user interface. Pretty cool, right? But to build that tunnel, ngrok needs to know who you are. It has to verify that you actually have permission to dig, and that means handling an authentication token. The absolute best practice here is to grab your auth token from your ngrok dashboard and immediately save it in Google Colab's Secrets tab. It's that little key icon over on the left sidebar. Name it carefully, something like PyNgrok_auth_token. Then, in your code, you securely call it using userdata.get. Why does all this matter? Because hard-coding your private token directly into a shared Colab notebook is a massive security risk. Anyone who sees your notebook could literally hijack your tunnel. Using the Secrets tab is the industry standard for keeping your credentials locked down.
Section 4. Launching your web app. All right, our tunnel is built, securely authenticated, and now it is time to actually get a working URL. When you're first setting this up, please resist the urge to write your magnum opus right out of the gate. Seriously, if you write 500 lines of complex Streamlit code and hit run, you won't know if a crash is due to a typo in your code, a Streamlit bug, or a complete tunnel failure. Keep your initial app.py incredibly simple. Just import Streamlit and write st.title, we did it! Your only goal right now is just to prove the connection works. Once you've verified the plumbing, then you can go ahead and build the mansion. The absolutely crucial point here is the order of operations in your final Colab cell. Here is a massive pro tip drawn directly from the Panaversity instructors. Set up your public URL and print it before you run the Streamlit command. By running ngrok.connect8501 and printing the result first, you generate the clickable link right there on your screen. Then, and only then, do you run the Streamlit run app.py command. Why? Well, because that Streamlit run command essentially locks the cell into a continuous, infinite loop to keep the web server alive. Any code placed after that command is never going to execute, because the cell is just hanging indefinitely. If you print the URL last, you might literally never see it.
Section 5. Fixing disappearing files. Okay, let's address the most dreaded issue of them all.
Picture this. You spend 2 hours meticulously writing your app.py file in Colab. It's beautiful. You close your laptop to go grab a well-deserved coffee. When you come back, a mysterious ghost has eaten your file. It's completely gone. That sinking feeling is just the worst. As instructor Zishan explained, Colab uses temporary storage. The very moment your session disconnects due to an activity, everything gets wiped clean. The permanent fix to save your sanity here is to mount your Google Drive directly to Colab. By saving your app.py right inside your mounted drive folder and copying that specific file path into your run command, your hard work is saved permanently. It's ready and waiting for you when you return.
Alternatively, students Humail and Daniel brought up another highly effective best practice during the cohort, the write file magic command. If you put %% write file app.py at the very top of a code cell, followed by all your Python code immediately beneath it, Colab will automatically generate and update that file every single time you run the cell. It creates this beautifully seamless workflow. You just tweak your code, hit run on the cell, and your app file is instantly updated behind the scenes. It's a total game changer.
Section 6. Debugging common errors. Welcome to the Troubleshooting Clinic. Let's squash the specific bugs that popped up the most for the cohort.
First up, the module not found error. The system just abruptly tells you there is no module named PyNgrok or Streamlit. Don't panic. This simply means you either forgot to run your installation cells first, or, and this is way more common, your Colab runtime restarted automatically after a period of inactivity and wiped your previously installed packages. Just scroll back up to the top, run those pip install commands again, and get everything back in place. Easy fix.
Next is the incredibly frustrating authentication failed, or auth token does not exist error. This one kept popping up for students like Paris during the live session. It's a classic mystery. You swear you copied it perfectly, you pasted it perfectly into the Secrets tab, but the system just flat out rejects you every single time you try to connect.
The foolproof fix here is almost always about exactly how you named it. The variable name in your Python code absolutely must match the name in your Colab Secrets tab exactly. I'm talking down to the casing and the underscores. And here's a huge tip. Watch out for invisible trailing spaces. Sometimes when you copy-paste your token or the variable name, an extra space just hitches a ride at the end. That hidden space will cause a massive mismatch. If you are stuck here, just delete the secret entirely, create a brand new one, type the name really carefully without any trailing spaces, and use that exact same name in your userdata.get function.
Finally, let's say you get past authentication. The tunnel is dug, but now the site just spins endlessly. Or Colab throws a localhost error complaining that your account is limited to one session.
The fix is simple, but it is so easy to forget. You have to kill your parallel sessions. Free ngrok accounts strictly limit you to one active tunnel at a single time. If you have another Colab tab open somewhere, or a previous cell is still actively spinning and holding that connection open, your new attempt will fail instantly. You need to explicitly stop your other cells by hitting the stop button next to the cell, or just going up to the runtime menu and restarting the session entirely. Clear your previous sessions from the ngrok dashboard if you need to, and just make sure you're only trying to run one single tunnel at a time.
As we wrap up today, I really want to leave you with this fantastic quote from the instructors. Learning continues beyond this quarter. If things aren't perfect yet, don't stress. Just keep your learning going. I really want you to take that to heart. Running into bugs, fighting with environments, and meticulously troubleshooting errors, that is exactly what being a developer looks like. It's literally 50% of the job for everyone, from absolute beginners all the way up to seasoned senior engineers. You are building invaluable resilience every single time you figure one of these out. So, I'll leave you with this question. What are you going to build in your newly stabilized Colab environment? Now that all the infrastructure headaches are out of the way, it's time to finish those brilliant data app projects. Thank you so much for joining this explainer. Get out there, write some code, and I'll see you next time.